The Okanagan College Centre of Excellence was conceived as a venue to teach the latest in sustainable technologies to the construction trades. Clearly, to do so, the building itself had to target the highest standards of sustainability. In order to avoid compromising these goals, at the first construction challenge, we needed a clearly defined benchmark to target. The Living Building Challenge, developed here in the Pacific Northwest, provides this new benchmark for sustainable construction that goes beyond the standards set in LEED Platinum. The challenge seeks built solutions that respond specifically to a project's immediate location, environment and climate. We will consider just a few of these responses. If the building was to truly be of its environment here in the Pacific Northwest, we had to consider the mountain pine beetle epidemic currently affecting British Columbia. Over 14 million hectares are currently affected, which is larger than the size of England. In some areas, 80% of all pine trees have been killed. In addition to the enormous environmental damage this has caused, many communities that are dependent on the forestry industry now face serious social and economic hardship as their lumber source disappears. It was therefore obvious to the whole team, in order to be of its place, the building had to respond to this crisis that was directly affecting the surrounding local communities and regional environment. It was essential the building had to be constructed of locally sourced pine beetle kill wood. Another part of the philosophy of the building is to return the control of the indoor environment back to the individuals. To do so, all working spaces have good access to daylight, views, and opening windows for natural ventilation. In the workshops and the gym, high-level clear-story windows throw light deep into these spaces. East-facing clear-story windows capture early morning winter sun to preheat these spaces, while the large roof overhangs shelter the same windows from the summer heat. In the Human Kinetic Suite and the Innovation Centre above it, a prototype solar tracking device is being trialled. An array of hundreds of small mirrors on the south elevation actively tracks the sun throughout the year. These focus, concentrate, and redirect the sunlight through horizontal ducts, and distribute it evenly throughout the 18-metre deep planned space. On warm summer days, fresh air is drawn in low across the spaces, cooled by the radiant piping within the floor slabs, using the natural cool temperature of the groundwater. As the air warms, the natural buoyancy of the warm air is allowed to vent out through a series of chimneys along the length of the roof, drawing more air in and through the building. The flow is enhanced further by utilising solar gain through the glazed panels on the south side of these chimneys to boost the stack effect. To achieve net zero energy use, we have broken down the process into 3 simple steps: conserve, capture, and create. Conserving energy through reducing losses and reducing demand is both logical and very cost effective. A high efficiency building envelope is used, incorporating many simple and widely understood principles. User plug loads are addressed with small LCD displays throughout the building, showing real-time energy use for each space and comparing these to target figures, in order to encourage responsible occupant behaviour and reduce these uncontrolled loads. Through passive means, the building captures free energy from its environment. The use of natural ventilation and the early morning preheat we have already discussed. Extensive glazing on the south uses the public space to trap heat from the low-angle winter sun for reuse throughout the building, but shading it against the summer heat gain. Through these and other simple techniques of conserve and capture, the energy demand for the building is reduced by 75% from that of a conventional building. The remaining 25% has to be created from renewable sources on site, with no combustion in any form. For this building, solar energy was the practical solution, both solar hot water and photovoltaics. Through a net metering agreement with a local utility, photovoltaics becomes a good fit for the college and well suited to the many hours of sunlight Penticton enjoys. The 260 kilowatt first phase will generate nearly 300 kilowatt hours per annum and is understood to be the largest array in Western Canada. The building is now finished and full classes have started for the first students. if we consider the process so far, what is most apparent is that it was not driven by a single champion. Instead, it has been created by genuine teamwork between the three groups, the college, designers and contractors, and strong cooperation and commitment from everyone within each of those teams. For the college, the project itself was initiated essentially through a groundswell of sustainable initiatives at all levels, which in turn was recognised by all levels of government. The college should also be applauded for their willingness to evaluate and take the risks needed to pursue these goals. Within the design team, it has been a unique and dynamic process. Ideas were freely bounced around, tested and challenged. The need was recognised by everyone that in order to meet the challenge, as well as budget and timescale, the building could not be a series of loosely connected independent designs, but needed to respond with holistic solutions. An example of this process is the gym. The timber floor in the gym prevented us using radiant heating and cooling in the floor slab, as we do elsewhere in the building. Instead, a unique wall panel was designed. The radiant heating and cooling pipes are contained within a thin concrete panel, which in turn is held between glulam columns. By creating a structurally composite connection between the two elements, the thickness of the concrete in the panel is reduced to only 75 mm. At 10 meters high and 3.6 meters wide, the equivalent precast panel would be at least twice this thickness. So this design greatly reduces both the overall mass of concrete in the construction and the embodied carbon. The construction team started as an integral part of the design process. They then faced the huge challenges of implementation, educating subcontractors and suppliers, and breaking new ground in material sourcing and technologies. When reviewing the self-assessment scores, in line with the targets set by the Living Building Challenge, the project scores close to best practice for both energy and resource consumption and indoor environmental quality. Culture and heritage has been omitted from the assessment as there was insufficient data that was relevant. When considered with the other parameters, the weighted building score is 3.06, within good practice. To conclude, working in the construction industry, we are privileged to be involved in the development of sustainable buildings. However, the inspiration and motivation for all three parts of this team is not the radical targets for the building itself, but the fact that it would be used to break new ground in teaching sustainable construction trades, and thereby influencing an entire generation of construction workers in the Okanagan, British Columbia and beyond.